In this video, we shall look at how to differentiate exponential functions and other functions that are related or associated with exponential functions. Let's start with the following basic exponential function, y equals to ex. How do we determine dy dx? The first thing to do is to take the logarithm of both sides. So the left-hand side will simply become log ey, and the right-hand side is log to the base e ex. So you see the right-hand side, log ex, is quite simply x, because when the x goes to the front, what is left is log e, and this is 1. So x simply becomes log to the base e of y. Now let's differentiate x with respect to y. This is quite simply 1 over y, as we have seen from our previous video. And dy dx is 1 over dx dy. That means it is just y. But we know y is just e of x. So that means dy dx is e to the power x. What if y equals e to the power of function of x? Let's call that function f of x. So what is dy dx? In this case, we can use a similar technique that we use to differentiate function over function. So what we can do is to rewrite dy dx as dy df times df dx. Now we know what dy df is. It is the same as e to the power fx. And what is df dx? It is just the derivative of f with respect to x, because f is a function of x. So the final result for dy dx, if y is expressed by that function, is the derivative of f with respect to x times the original function e to the power fx. Let's see how to differentiate this function, e to the power x raised to the power 3. This is quite simply e to the power 3x. So 3x here is like your fx in our previous discussion. So dy dx equals d dx of that 3x times the original function, which is e to the power 3x. And this is quite simply 3e 3x, and that's the final answer. What about this function? As always, your tangent x is your fx, so dy dx equals d dx of that tangent x times the original function e to the power tangent x. Derivative of tangent x with respect to x is quite simply secant squared x, and that multiplied with the original function e to the power tangent x is the final answer that we seek. Let's look at the following function. Of course, it has exponential functions as an argument of the logarithmic function. So the first step is to define a function f as e to the power x over ex plus 1, namely the argument of that natural log. So now you see y simply becomes natural log of f. So dy dx can be written as dy df df dx. Now what is dy df from here? It is 1 over f. And what is df dx? Now that can be determined from this function. So let's determine that first. df dx. Now we can use the quotient rule. First, take the derivative of e to the power x. That is just e to the power x. Write down the denominator, e to the power x plus 1 minus Now take the derivative of the denominator. That's going to give you just e to the power x, and then you multiply with the numerator, e to the power x, divide by the square of the denominator. This is quotient rule. And you see that two things will cancel. Ex times ex minus ex times ex, leaving you with just e to the power x over e to the power x plus 1 squared. So let's substitute this in here. E to the power x over e to the power x plus 1 squared. Since f is defined by this function, your dy dx will become 1 over f. That means ex plus 1 over ex, inverse of f, times ex over ex plus 1 squared. So you see that this ex will cancel that, this will cancel one of that, and will give you the final answer as 1 over ex plus 1. And that is dy dx, where y is defined by that function. Problem 4. Y equals inverse of sine of e to the power x. So what is dy dx in this case? Before we find the derivative, let's express ex in terms of y. That is simply sine of y. So x equals natural log of sine of y. Now this enables us to determine dx dy. So dx dy, now let's assume that the sine y is a function g. So dx dy is dx dg times dg dy. Dx dy is 1 over g. And dg dy, since g is sine y, dg dy is cosine of y. And since g is sine of y, cosine of y over sine of y is cotangent y. Note what we have calculated here is dx dy. So dy dx is just 1 over dx dy, which in this case will be tangent of y. Now tangent of y is sine of y over cosine of y. Now we know sine of y in terms of x is e to the power x. So your dy dx will be e to the power x over cosine of y. So what is cosine of y in terms of x? It is square root 1 minus sine squared y. And sine y is e to the power x. So sine squared y is e to the power 2x. So you have the final answer. Dy dx is e to the power x over square root 1 minus e to the power 2x. Let's look at the fifth example. How do we find the derivative of this function with respect to x? We simply use the quotient rule. So dy dx equals, let's differentiate the numerator. You're going to get e to the power x plus e to the power minus x. Multiply that with the denominator, e to the power x plus e to the power minus x, and then minus. Now differentiate the denominator, and you're going to get e to the power x minus e to the power minus ex times the numerator, e to the power x minus e to the power minus x. Divide this entire thing by the square of the denominator. Let's simplify the numerator. So you have e to the power 2x, this times that, plus e to the power minus 2x, this times that, and the cross terms will give you 2, minus this times that, e to the power 2x, this times that, plus e to the power minus 2x, and the cross terms will give you minus 2, over ex plus e minus x squared. A few terms will go away. This will cancel that. This will cancel that. And will give you 2 plus 2, that is 4, over e to the power x plus e to the power minus x squared. And that is the final answer. Let's look at this problem. Y equals 2 to the power x. So what do? You take the natural logarithm of both sides, and you're going to get x natural log of 2. So you can immediately write x in terms of y as 1 over natural log of 2 times natural log of y. So let's first compute dx dy, and that is just 1 over natural log of 2 times 1 over y, because the derivative of natural log of y with respect to y is 1 over y. So what that means is dy dx is y times natural log of 2. Since y is given by 2 to the power x, you get 2 to the power x natural log of 2 as the final answer. Now let's try to differentiate x to the power natural log of x with respect to x. So the usual trick is take the natural log of both sides. So you're going to get natural log of y equal natural log of x raised to the power of natural log of x. Now we know from the property of logarithms, this power can be brought to the front, and you're going to get natural log of x times natural log of x, which is natural log of x squared. So that is the natural log of y. So y is just e to the power natural log of x squared. Note that this is just a function x that we talked about at the beginning of the video. So dy dx is d dx of that fx, which in this case is natural log of x raised to the power 2 times the original exponent, namely e to the power natural log of x squared. And since this is the same as that, we can replace this with just that. So this becomes x to the power natural log of x. Let's try to differentiate natural log of x squared. Now that is easy. The 2 goes in front, so it becomes 2 natural log of x, and now you differentiate natural log of x, which is 1 over x, times that, which is x to the power natural log of x. And that's pretty much your answer. You can rearrange it. So 2 times x raised to the power natural log of x times natural log of x over x. And that solves the problem. And last problem. Y equals sine x raised to the power x. So as always, let's take the natural log of both sides. So you're going to have natural log of sine x to the power x, and this x can go to the front, and you're going to get x natural log sine of x. What that means is y is e to the power x natural log of sine x. So this and this are equivalent forms. Note this power is just fx, it's a function of x. So dy dx is df dx times this original function, which is just that. So sine x raised to the power x. So let's differentiate this function with respect to x. We can use product rule. So this is the first function and this is the second function. So differentiating x, you get 1, you multiply the other function with 1, so sine x plus x times you differentiate the second function, which will give you 1 over sine x times cosine x, and multiply the entire result with sine x to the power x. And there you go, the desired final result. Thank you for watching.